So in this video we're going to be graphing an ellipse given its equation, and here I've written down the two main equations that we'll be using for an ellipse. And in the last video, if you watched it, we were just assuming that the center was at the origin. So in this one, we're going to assume that they're not at the origin, so they're going to be in different places. And the center, let me get my pen, the center is going to be HK. And notice that the formulas are very similar. It's x minus h squared over a squared plus y minus k squared over b squared. And then in the other one, it's just y minus k squared over a squared plus x minus h squared over b squared equals 1. And notice that when x is bigger, we're going to be longer than we are tall. And when y is bigger, we'll be taller than we are wide. And let's just get started. Okay, so immediately when I look at this equation here, I notice that, well, you know, a squared, the a squared term is determined by whatever one is larger. A squared is the larger denominator. That's really important when you work with ellipse. I emphasized that last time in my first video, but let's still do that here. A squared is the larger one, so that means that really we could rewrite this, and I probably would recommend it just in the right order. We would have y minus 2 squared over 9 plus x minus 5 squared over 4 equals 1. The reason I would rewrite it is then because we have the a squared first and the b squared second, and that just makes more sense to me. That's just like the way I would see it. So let's have that there, and then now the next thing I would do is find the center. The center, as we know, is h and k, and h is just whatever term goes with the x, so that's a 5 in this case, so we've got 5. And then, well, the k term is just whatever one goes with the y, so that's going to be 2. So we've got our center, 5, 2. 1, 2, 3, 4, 5. 1, 2. So now we just need to find our vertices around that center, and we'll have like a general oval shape for us to work with. So our major vertices, because the major axis is always 2a, so if the major axis is 2a, so that equals 9, well no, it equals 6. So a equals 3. I got that from doing a squared equals 9. And then square rooting both sides, a equals 3. So then we know the full axis, which means this way and this way, is going to be 6. So we're going to go up 3 and down 3. We're going to go up the value of a and down the value of a. And we know we're going up and down here because it's under the y term. And then, well, b squared equals 4, so b squared equals 4, so b equals 2. And that's under the x term, so we're going to go to the left 2, and we're going to go to the right. We're going to do the right 2 and then to the left 2. So our major vertices, let's write them out here. Only the y value is changing for the major vertices, so we're going 5, and then we're going 2 plus or minus the a value, which is 3. So there are 5, 5 if we add the 3, and then 5, negative 1 if we subtract 3. So 5, 5, 3, 4, 5. Say it's right there. Then 5, negative 1, we'll say right here. So those are our major axis vertices, and then we have minor vertices, which we decided was going to be moving in the b direction. So that's obviously our x is changing and our y is going to stay the same. So we're going to have 5, because that's our original x value, plus or minus b, which we know is 2, so 5 plus or minus 2. Then all of it will have a y value of 2, so it'll be 7, 2. And then 5 minus 2, which is 3, 2. Those will be our two minor axis vertices. So 3, 2 gets us, I did not do a good job of writing out my points, we'll put it here. Just forget about that. And then 7, 2, 6, 7, we'll put it right here. So then we've got our little oval shaped ellipse. Did not really connect that dot, but that's fine. Okay, so now the only thing we have left is the foci. And foci, as we know, always go in the direction of the major axis. And we also know that c squared equals a squared minus b squared. Well, c squared equals, it's going to be 9, which is a squared, minus b squared, which we found was 4. So c squared equals 5. C equals square root of 5. And then so we know our foci will be at, our x value is going to stay the same, so it's going to be 5, and then it's going to be 2 plus or minus the square root of 5. And that'll be our foci here. So now we can put that in the chart. We know the square root of 5 is a little bit more than 2, a little bit less than 3. So it'll be roughly like around here and then around here. And at that point we have all of our major points. We've got the 2 foci, we've got the minor vertices, we've got the major vertices, and we've got the center. And so we've graphed it and we're done. Alright, so now let's look for the next one. If you want, you can try this on your own before we get into it. If not, let's go. And this one, first thing you should always do with an ellipse, see the denominators. The larger one is on the left, so that means that's a squared. Remember, the larger one is always a squared. B squared's here. So if a squared is 16, well, we can finish the center first. Well, it's going to be the h is paired with the x, and that's a 1. Then the y, see how it's y plus 3, and the formula calls for y minus k. Into a y plus 3, we know that it's been y minus the negative 3. So that is what k equals, negative 3. So 1, negative 3. So that's our center, so we can draw that in. 1, 1, 2, 3. That's the center of our ellipse here. And then, well, we see that the x has the bigger one, so we know it's going to be longer to the left and the right than it is up and down, and that's important. And so we're going to go over this way by the value of a, then we're going to be over this way by the value of a, we're going to be up by the value of b, and we also will be down by the value of b. So let's think about that. Well, if a squared equals 16, a equals 4, so we're going to go to the right 4, we're going to go to the left 4. If we started at 1, negative 3, so let me write this as our major vertices. If we start at 1, negative 3, now we're just going to be 1 plus or minus 4, negative 3. And the 2 points there will be 1 plus 4 is 5, negative 3, and 1 minus 4 is negative 3, negative 3. So 1, 2, 3, 4, 5, we're right there. And then negative 1, negative 2, negative 3, we're right here. So we've got those two. And then for our minor axis vertices, like we said, we're going to go up and down by the value of b, and we found b to be 2, so we're going to take our original function. This time the x is going to be staying the same, so we're going to have 1, but then we're going to have negative 3 plus or minus that b value of 2. So we'll have 1, negative 1 if we add 2, then 1, negative 5 if we subtract 2. So those are our two minor axis ones. We've got 1, negative 1, 1, negative 4, 5. Then we can draw our ellipse, close that circle. That was a terrible ellipse. Sorry about that. It's hard to draw on here sometimes. And then we have our foci, will be the last thing we figure out. We know the formula now. It's c squared equals a squared minus b squared. So c squared equals 16 is a squared, minus b squared is 4. C squared equals the square root of 12. Well, c squared equals 12, so c equals the square root of 12. So then we're going to take, well, since the x term comes first, we've got to add that. The focus is going to be changing the x value. So we're going to have 1 plus or minus the square root of 12, and then negative 3. So those will be our two foci, and if you draw them on the graph, square root of 12 is a little bit more than 3, less than 4. So it's going to be about like, well, 1, 2, 3, it'll be like around here, then around here. So those are our foci, and those are our major vertices and our minor vertices, and that's about all you need to know to be able to graph an ellipse. I hope you enjoyed this video, and I hope it helped.